In the beginning, we will discuss some points regarding SEG storage tanks module. Let's ask, what is SEG software? It is an engineering application. It's a design automation tool and a productivity tool for 3D modeling and detailing of static equipment. Static equipment here means many types of static equipment, and we will discuss the available types in SEG software. You can generate the 3D model, fabrication drawings, complete and detailed bill of material, sheet metal development, and many other things. In SEG software, it's the only existing software can generate vertical and horizontal pressure vessels, columns with different diameters and the transitional sections with different thicknesses, storage tanks with fixed roof, steam and heat exchangers, equipment, piping, plug catcher, ducts, and spherical tanks. The only existing software can do all of this stuff under one umbrella. You can save up 80% from your time and money in case of using SEG software. Here, that's a real case for a horizontal pressure vessel. We studied this case in 3 different methods. The first method by using the traditional way, which is using AutoCAD. And from the below chart, you can figure that we consumed around 50 hours to generate the general arrangement drawing, a complete and detailed bill of material, and the other detailed drawings for the clean our manway, support saddles, nozzle details, and nameplate. By using another method, which is using a pure CAD software like SolidWorks or Autodesk Inventor, we consumed around 10 hours to generate 25 hours to generate the 3D model, and around 10 hours to generate the fabrication drawings, totally around 35 or 38 hours to generate the complete 3D model and detailed drawings. By using SEG software and Autodesk Inventor as a platform, we consumed around 3 hours to generate the 3D model and around 5 hours to generate the fabrication drawings. Totally, we consumed around between 7 and 8 hours to generate one day, you can say, one day to generate a complete and detailed drawings for this equipment. Sometimes if you have a simple equipment, you can generate it in 2 hours or 3 hours, a complete 3D model and detail the drawings. Here, a sample for some actual cases created by SEG software. That's a team heat exchanger, tagged team heat exchanger, double vessels with a type AES type. That's a horizontal vessel with internal piping, completely done on SEG software. Another vertical vessel with some internal. A storage tank with a heating coil at the bottom. Another storage tank with a spiral stair with a simple roof structure. A reactor. And you can figure out the detail of plate arrangement here for this reactor. Some detailed drawings for storage tanks and plate arrangement on roof and bottom. Another drawings for some vertical and horizontal pressure vessels. Some details for some attachments like support saddles, nozzle details, tube sheet, stacked saddle, nameplate, spherical tanks. Okay. By using SEG software, you can generate a 3D model and the detailed drawings. You can generate a complete and detailed bill of material. You can make the nozzle opening on the shell plates. You can get the sheet metal development for plates. You can export the 3D model in many different extensions. The same for the sheet metal development. You can export it in GXF extension or DWG extension. You can generate estimated material cost report for your equipment to estimate the price of the materials required for your equipment. Inshallah, in the next slides, we will discuss the available features for the storage tanks in SEG. Here we will not discuss the pressure vessels or columns or steam heat exchanger. Just only we will discuss the on the next slides the available features for the storage tanks. In SEG software, we have a tool give you the ability to arrange the blades for the roof and bottom. And we will discuss the available features in this module during our presentation, inshallah. By using SEG software, you will be able to generate different types and elements to generate the 3D model for the storage tank. You can add annular plates, bottom plates with different types, shell plates with different types, compression rings, anchor chair, manways, clean outdoors according to the API, spiral stairs, drain sump, lifting lugs, and many other attachments. For example, for the annular plate, you will find 3 different types for the annular plates. The first type for the equal annular plates, if you have a certain number of annular plates and they are identical. Okay, so you can use this type of annular plates. Another type, if you would like to define a separate thickness or a separate arc length for each annular plate, so you can control each annular plate separately. In that case, SEG, you can select the suitable type for that to give you the ability to define each annular plate separately. Different types for bottom. You can make the bottom of this tank as a flat bottom, like that case here. You can make
just a moment.
Yes.
Sorry, Ahmed, please continue.
Okay.
Can you go back to one slide back?
Okay.
Yeah. You were discussing on the second point that for each annular plate we can define the length, and then please continue from there.
The second type, you can define the arc length separately, so you can control the arc length for each blade, but all of them with the same thickness. Okay. The third type, they will be different, but you can control the thickness too. So each annular blade, you can give it a different thickness. That's in case, let's say, if you have a clean outdoor, this clean outdoor required annular plate with a different thickness from the other annular plates. So you will use this type, which is annular plate from different pieces and thicknesses. Okay, so you can define the annular blade for the clean outdoor as so you can control the arc length, you can control the thickness of this one. Okay. Here for the bottom plate, you can make it as a flat bottom, so it will be horizontal, like that. You can make it tilted in one side, so the annular plate can be tilted like that, or it's sloped to inside, like that, or sloped to outside, so the drain sump will be at the outside here. On that shape, which is too sloped to inside, the drain will be on the middle. Okay, so those are the types for flat for the bottom plates. Another option for the shell plates, like the same which we discussed on the annular plate. Here on the shell plates, SEG will give you the ability to select between different 11 or more than 11 types of shell types. But for tanks, let's discuss 3 important types. The first type, which is shell from different pieces. Here, for this shell type, you can define the arc length for each blade inside the shell. Let's say most of us know that is the storage tanks generated from diameters maybe more than 6 meters or something like that. So one sheet will not be enough to generate the complete shell course for this tank. So we need more than one blade to make the shell course. SEG give you the ability to define the length of each blade separately. That's the first, but all of them with the same thickness. Okay, all of them with the same thickness. Another type, which is shell from different pieces and the thicknesses. This type will give you the ability to control the thickness of each blade on the shell. As we discussed, for the clean outdoor, you may need to increase the thickness of the shell in this area. Okay, so you can make the course one sheet on this course with a different thickness for the clean outdoor. So this type will give you the ability to control the arc length and the thickness for each blade. Okay.
Okay.
A compression ring. The compression ring in SEG will you can select the suitable compression ring for your case based on the API. And for the roof, you can make a radial roof with radial blades as slices. Okay, you can make it as a ranged roof plate like that shape. You can arrange the blades. You can make it a dome roof as arranged blades. The same option for dome roof. You can make blades like that, or you can make the dome roof as a radial plate. Here in this video, we will generate a roof for a storage tank with 42 meters diameter. Okay, so from here, we will define the delivered blade dimensions. Okay, and we will add a ranged roof. And from here, we will define the top inside diameter and the thickness of the roof, the slope of the roof, and the bottom inside diameter. From here, we will start arranging the roof plates, and in each row you will find an origin blade. This origin blade you can move it to make it aligned to left, to right, or to center. You can control the offset of this origin blade. Many options you can do. The same for the rows. You can make them vertical and merge some rows, and that will give you a flexibility to change the configuration of the blade arrangement. Okay, and we will discuss that inshallah during the demonstration. Okay, after creating the arrangement, you can save it. After that, you can send the information to Autodesk Inventor to generate the 3D model. As you can see, the roof plate arrangements are created on Autodesk Inventor as a separate parts. Okay, so you can get a detail for each plate if you would like to make that, and get a detailed bill of material for this roof. Here, the plate arrangement, and for the bill of material, automatically you will get the detailed of plates and the weight of each plate. You can add another attachments like the anchor chairs, and there are different types from the anchor chair. The first type, the anchor chair with a complete top ring. In some small tanks, this chair include a top plate like that, but for the small tanks, it may include a ring instead of separate plates. So the first type including a ring, the second type including support with a clip right like that, and the third type for the anchor chair suits the tilted bottom tanks. Here for the clean outdoors, there are three different types of cover hinging. So you can select the suitable davit for the clean outdoor. That's based on the size of the clean outdoor. For the small sizes, you can use this type. For the mid sizes, you can use this type. For the large sizes, you can use this type of davit. You can generate the spiral stairs for the storage tanks and multi-levels. Nozzles according to the API, so you can select the size of the nozzle as a nozzle from pipe or a nozzle from plate. So the neck of the nozzle can be generated from pipe or from plate. You can add a circular repad or a diamond repad. You can make it a low type as a circular or diamond repad. And if you would like to control the dimensions of this nozzle, you can select the user-defined thicknesses, so you can control the dimensions to make it not equal the API dimension. So here you will find the API dimensions appear here. So if you would like to change, just select user-defined thickness to change the thickness of elements. Okay, for the roof structure, here in SEG software, it's available to make a simple roof structure from beams like IBE or HEA, like that, and you can make stiffening or bracing like that in 2 levels, up to 2 levels. But for the truss structure, it's not available in SEG software, but you can make it by using the tools of Autodesk Inventor, by using the frame generator tool on Autodesk Inventor. Here, this model already generated by using this tool from Autodesk Inventor. Okay, so this truss structure we created on Autodesk Inventor, not in SEG software. For the ladders and platforms, in SEG software, it's available to make platforms and ladders as a one part. That means it will appear on the bill of material as a one part, not a detailed item. So you will get the grating as a separate part and all the platform as a single part. You will not get a detailed bill of material for the platform. The same for the ladder. You will get an item on the bill of material. This item notes that we have a ladder with a length like that and a weight like that, the weight of this item like that. Okay. For the other attachments like the ladder clips, ladder supports, or any other attachment, it will be in detail. So you will get a detailed bill of material for those items. So here for the previous slide, the truss structure is not available. And for the ladder and the platforms, you will get them as a single part, not a detailed parts in bill of material. You can make a nesting for the plates by using Autodesk nesting tool, and that will give you the ability to save the material because this tool will arrange the plates to give you the best cutting performance. Here in this video, we will make a nesting for the annular plate. So let's select the annular plates and generate a nesting study. Okay. After that, we can define the available plate dimensions that we will use it in nesting. Okay, the length and width for plates. After that, we will start nesting study. Okay, here SEG will proceed to calculate the required number of plates. If we come back here a little bit, okay, you can figure that the nesting efficiency is around 80%. So we will lose around 20% from the plates. And here the number of parts, we have 12 annular plates, and we will need 3 sheets for the annular plate. And you can figure that that's the arrangement of the annular plates for this assembly. There is another tool in SEG, which is a parametric modeling. This tool will give you the ability to make constraints between elements. So, for example, if you have a shell like that figure here, you have a shell with inside diameter and a reduced cone with eccentric, reduced cone with in the inner diameter. You can make a relationship between those parameters. So if you change one of those parameters, automatically it will be reflected to the other. Let's watch this video. Here we have 2 elements, shell and head. Okay, they have different inside diameters. By using the parameters relationship, we can make a mapping or make a relationship between the inside diameter of the head, and from the right hand side we will select the shell and select the inside diameter of the shell and make a relationship between. So both of the inside diameters will be equal. Okay, so in case of changing one of them, so let's change one of those side diameters to 1.5 meters, for example, and click save. If you select the second item, automatically the inside diameter for the second item will be changed. Let's repeat it for the thickness. Let's make a mapping for the thickness. Select the thickness of the head and the thickness of the shell. We make them equal. So in case of changing one of them, it will be reflected to the other. Click save. Now if you open the left head, you will get the inside diameter of the head changed. So you can make a relationship between the connected items, okay, like that figure. You can export your bill of material. You will generate a detailed bill of material for your equipment, and you can export this bill of material in Excel format. So any other department in your company, some of your colleagues need a bill of material in Excel format, you can send it to him to proceed with another process. You can generate an estimated material cost report for your equipment. You can generate a nozzle opening by using a tool for the this tool used to generate the nozzle opening on the shell, and that will give you the ability to get the sheet metal development with the nozzle opening. You can get sheet metal development for all blades in your project by using flat pattern tool in SEG software. You can export the 3D model in many different extensions to many different CAD software like CATIA, Pro Engineer, SolidWorks, AutoCAD, and many other applications. You can export the sheet metal development to DWG extension and DXF extension. You can export your drawings to many different extensions. For the drawings, you can make a general arrangement drawing for the equipment, make sub-assembly drawings for the attachments, make a detailed drawings for some nozzles or other attachments. You can include pre-built tables to your drawing, like the bill of materials table, design data table, nozzle table, and many other tables. For the nozzle table, for example, you can include the nozzle tag, nozzle service, nozzle size, the attachment for this nozzle, and many other options. For the drawing template and welding details, you can include your standard drawing template to SEG software to use it as a reference drawing in IDW extension. So anytime you will generate a drawing, automatically SEG will use your reference template. You can add a welding detail from SEG welding detail library. So it's a huge library for welding details. You will select the suitable welding detail for your equipment to add it to the drawings. If you would like to add your own welding details, you can add it as a block or the 3D model for your drawing. As you can do that with AutoCAD. So Autodesk Inventor drawings, you can deal with it as dealing with AutoCAD. Okay, some of the available types of nozzles on Shell. SEG includes more than 23 types of nozzles. So those some of the famous types, like nozzle from pipe. So the neck of the nozzle will be formed or fabricated from pipe. Nozzle from blade. The neck of this nozzle will be fabricated from a blade. Long weld neck nozzles, self-reinforcement long weld neck nozzles, forged hubs, forged hub with lips, rectangular opening, oval opening, and many other types of nozzles. Some other types for the supports available in SEG software. For example, for vessels and towers, you can use saddles, stacked saddles, tilted saddles for tilted vessels, skirt, support legs, lugs for vertical vessels, anchor chair for storage tanks, and support legs from standard hot rolled sections. Some other types of cradles for small vessels. Many different types of lifting lugs available in SEG suits different positions of the vessel, like horizontal vessels, vertical vessels, small sizes, large sizes, like trunnion, and here different types of trunnion, different type of lifting lugs. And here some other details for each type of the lifting lugs. It's actually, you can use it for vessels for the most options. Okay, now let's start generating our demo of today. Okay, here that's SEG software, and we will generate a new project. So from here, let's generate a new project. So that's the name of project, demo, with the date of today. Okay, and let's select the project location. So let's select the desktop, and from here you can select the module of the project. In our case, we can select the tank module. That module will give us the ability to make a roof and bottom plates. And in case of using overall module, this overall module gives you the ability to generate tube sheets for heat exchangers. You can make spherical tanks parts. You can make a piping or ducts. So the overall module will give you all features of the other modules. In our case, let's select tank module, and by clicking on finish, SEG will generate a project folder. Okay, this project here you can figure that that's SEG tree. The SEG tree here includes different levels. The first level is the project level. Here you can define the project information like project number, plant number, client, manufacturer, all of that. And for the tank level or the equipment level, you can define the design data of this equipment, like the construction code, design pressure, internal design temperature, all of that. You can make a rename for the equipment. So let's rename this equipment as a storage tank. Okay. And from the setting here, let's select equipment setting. And from this form, you can change the position of the vessel. Automatically, in case of using storage tank, automatically SEG will change those values, which is vertical. That's the position of the tank. It will be a vertical. And here, the direction of the assembly will start from bottom to top. So you will start from the bottom plate, shell plates, up to the compression ring and the roof. So the direction of the assembly will start from the bottom to top. That's the default position in case of using storage tank. Here we can define the delivered blade dimensions that available on our stock. So let's define the length and width of the available blades. You can define the service of this tank. That's the service of the tank, and here that's the serial number. And let's click on save. You can change the units of this model from English to metric and select the precision of units like that, and let's click on save. Now let's start creating the first element, which is the bottom blades. Okay, let's open the notepad, and from here let's make a storage tank with inside diameter, let's say 9 meters inside diameter.
Yes. Ahmed, can we go with an example of like 40-meter dia tank?
Okay, 14?
40.
Okay, yeah. No problem, but we will have a lot of plates on roof and the bottom, so it will take a time in rendering. Okay, no problem.
Okay, no problem. You can go ahead with your example, no problem.
Okay. And here we have the bottom plate, and let's make like that and change the color here. So we have 10 millimeters thickness here for the bottom plate. For the shell plate, we have 10 millimeters thickness, and here 60 millimeters projection for the bottom plate. So totally here, the inside, the outside diameter of the of this bottom plate will be that value plus double that value and double that value, which is equal 9. So let's repeat it here.
Yeah, it's correct.
20 plus. So that's the outside diameter of the bottom. Okay, so from here, let's add the first part, which is flat bottom. So you can figure that you have different types. Sloped bottom. If we open the presentation here again, sorry, for the available types for the bottom. here for the bottom, you can figure that you can make it a flat bottom, tilted bottom, sloped to inside or sloped to outside. Here in SEG, if you open the element API elements, you will find arranged sloped bottom. Okay, in this bottom you will find those three types. Okay, which is tilted, sloped to inside, and sloped to outside. In this case, let's add a flat bottom. Okay, so and for the bottom here, when you select this item, this form will appear, and we can define the bottom plate dimension, the thickness of the bottom, the overlap, and the diameter of the bottom plate. As we calculate, it will be with that value. Find the material and the cut, torsion cut tolerance. This value, which is torsion cut tolerance, will give you the ability, if you have a mid plate, we have, as we discussed, we define the, let's make a new one. We have 6 meters length here and 150 millimeters width of the blade. Okay, and here if you make a cut by using the torch, so and you have a mid blade, so that means I mean here, if you have two equal blades and you will make a cut for this blade, so you will lose some area. Sorry, so you will lose area here based on the cut torch tolerance. Let's say it's 20 millimeters. That's the tolerance of the cut. So the value here will not be 3,000 millimeters. It will be 3,000 minus 10. Okay, 10 in this side and 10 in this side. So it will be like that. Okay. So you can define the cut tolerance, torch cut tolerance. So that will be the correct value. If you would like to make it 0, so you can define the torch tolerance as 0 from here. Now let's select the scale of the next drawing, save this, and open the update. Here we have the blade, the bottom outside diameter, and on the next step, we will make the arrangement of plates. Here you will find some options at the beginning before proceeding with plate arrangement. Those options will give you the ability to change the general configuration before go in deep. Here, for example, let's select mid row. Okay, that means we will get a mid row here. So let's get a new one. If we have a plate like that, so you can make a mid row here on the middle. Okay, so you will have a mid plate on the center of the roof. So if you click on row, you will get a plate like that. Okay, so let's remove this one here. Okay, I need to check the setting. Sorry, we didn't save this value. Meters 1. And let's save that. Let's come back here and open the plates, change the scale. You can figure that if you open that, the scale is a small scale. If you change that and click on save, you can increase the scale. So if you click the mid row and row plates, you will get this configuration for the bottom. Let's check another option before changing it. Let's reset the grid and check the all center and click row. So you can figure all blades will be centered like that. So a large blade, half blade, large blade, and another large blade. And if you want to make that one as a half blade, you can make it as a half size like that. Okay, and that one make it as a half size, or you can change the width of this one. For example, if you would like to make it 1.5 meters like that, so you can control the dimension of each blade by that way. Let's check another option. Let's remove this one and make it reversed, and click draw plates so you can reverse the direction. And let's update it. Let's remove this option and click on draw plates, so you will get this shape. I think this configuration is okay. Now you can define the orientation of this plate. So 0 degree will be here. So if you would like to rotate all of that line 24 or 45 degrees, so you can change it from here, but we will keep it at 0 degree. So let's click on 0 and click on save. Now we have the bottom plates, and we need to generate it on Autodesk Inventor. Okay, if we click on the assembly part, it will be generated. But in that case, the rendering of the element during creation will be generated on behind. You will not figure out the elements during creation. You can figure that. Autodesk Inventor takes the order and create the parts and the assembly of the bottom on behind. You cannot see that. But if you would like to make a rendering for elements during creation, we will select an option, give us the ability to render the items during creation. Here we have the 3D model of the bottom, and if you take a look here, you have the assembly from different parts. Here, if we open that assembly like that, you can figure that you have the first element here. That's the first plate as a separate plate. That's the first one. So each part here created separately, that one, another plate, so you can make a nesting or a detail for that one. Okay, so let's select the option of rendering of elements during creation. From setting and app setting, let's select child preview and parent preview, and let's click on save. And from here, let's select a shell element. Let's add panel. Okay. And from yes.
Sama, just here 1 minute. Now you have generated the bottom plate model in the Autodesk Inventor. Now we see the whole bottom plate with the small, with all the bottom plates, sketch plates, full plates. Mm-hmm. Okay, and now how easily I can generate the detailed drawing? Like, in the detailed drawing, each part will be marked with a with a mark number and give the details of the length, width. Is that also a simple method that how you have generated this bottom plate?
Okay, we will discuss that during the demonstration, inshallah. After generating the 3D model, we will proceed by making a detailed drawing for the bottom, a general arrangement drawing, and how we can import the bill of material for each element. We will make a separate drawing for the bottom with a detailed bill of material in the drawing, and how we can reflect the item number for each item on the Autodesk Inventor. We will discuss that, inshallah, during the session.
Okay.
Don't worry. Okay. Here, let's add a can, and from here you can figure that you have many different types of shell, like shell as a pipe, shell as a welded pipe, a shell without welding line. But for our cases, for the storage tanks, we have three important types. The first type, which is shell from different pieces, and that type gives you the ability to generate the required number of plates, defined each plate separately as a plate length. Okay. The second type, which is different from pieces for sloped bottom, if you have a tilted bottom for a vessel, so you can select that type for the first shell type. And a shell from different pieces and the thicknesses. For that type, you can control the thickness of each plate. In that case, let's select a shell from different pieces, and automatically you will get this message, which is inform you that the height of the plate in the default option for the available plates is 1.5 meters. So you will need to change the height of the course based on the values that you imported on the delivered plate or the available plate dimensions. So from here, let's define the inside diameter, which is 9 meters, and here the height. We will make it 1 meter, 0.5, change the thickness to 10 millimeters. Define the number of blades in this shell code. Let's keep it 3 and calculate that by clicking on generate the update the grid. Here SEG will inform you that the available blade length is 6 meters length, and that number, which is 3 segments, will not be enough. You will need to increase that number because the blade length is not will give you the correct value. So from here, let's change the first blade length. So you can change the length of each blade here, and that's the third blade. It's more than the available blade dimension. So let's increase the number of segments and click on update. So you can figure that we have 5 blades. The first blade here is 6 meters, 6 meters, and the last one calculated automatically. The length of the last blade calculated automatically. Here, let's change the first longitudinal welding line orientation and click update. Automatically, the other welding lines will be, the orientation of the other welding lines will be calculated automatically. So any change here, so for example, if you make this 5 meters and 0.5 and click on update, you can figure that the last blade automatically calculated. So let's back like that. So the orientation and the last blade and the inner welding lines orientation calculated automatically. Now let's click on save, and from here, if we click assembly, you will figure that after selecting preview or rendering for elements during creation, you will be able to watch the element during creation and assembly. Okay, that's the first course. It will be assembled and automatically assembled to the model. Let's add another 3 shell courses. Let's add CAN 2, and let's make it looks like CAN 1. Okay, so by selecting select part same CAN 1, that will give you the ability to make the same dimensions, but here you can make some changes, like here that the thickness, let's change the thickness, and let's change the start angle. Okay, we need to make an offset between the welding line for the second part with 30 or 3 meters, for example. So here we have a calculator to calculate the arc length. We need to make an offset with 3 meters offset. So that's the arc or the angle required. So we can take this value, copy, and paste it here, and click update. So the longitudinal welding line orientation will be changing. And now let's click on start assembly. Okay, the second shell course will be assembled like that. Okay, as you can figure here, this welding lines comes on the middle of this one, because the length of that one is 6 millimeters, and to calculate the orientation or longitudinal welding line orientation to make it on the middle, we use the calculator to calculate that, to give us the orientation or longitudinal welding line orientation. Let's add another 2 shell courses, CAN 3, and let's make it looks like CAN 1, another CAN, which is CAN 4. It looks like CAN 2, and click on save. And for CAN 3, let's change the thickness. Let's make it 8 millimeters and click update, click save. And for that one, we will keep everything as it is. Now let's start the assembly. The third CAN, the last CAN, Okay, now let's add a compression ring. So from here, let's select the equipment, and from elements, let's select the compression ring. Here from the compression ring, let's select detail B. You will find different types of details. So it's based on the API. So let's select detail B, and from here, let's define the bend diameter. So let's check that here. If that's the top can, we have inside diameter here. And 8 millimeter thickness. So the bend radius here, which is that line, will be, so that's the bend radius of the angle. So from here, let's define the bend radius, and the offset of this angle here, the offset from the facing of the angle from the end of the shell. Let's make it 10 millimeters, and from here you can select the suitable standard for the angle, like Australian code or European code. Let's select European code and select the angle size L100, 110. Okay, and let's click define the material and click save. Okay, and from here let's click on simply to generate the compression ring. Now let's generate the roof. From here and from elements, let's select arranged roof. Okay. And for the roof, let's define the opening here. Find the thickness of the roof to be 8 millimeters. The slope of the roof 1.5. The overlap and the end inside diameter. Okay, here we have an equal angle. Like that. Okay. And the roof will be here like that. So the offset from that line, so let's select another line with another color. So the diameter here, let's say we have 40 millimeters in each side. So that value will be increased with 80 millimeters. Okay, so the inside diameter, or the diameter of the roof will be like that. And that's the torch cut tolerance. Change the scale and click on save. Now let's open the plate arrangement for the roof. And from here, let's create a draw for plates. So we will get this arrangement as a default. You can change the blade arrangement if you would like. And here we will discuss another option. Let's reset the grid. Let's make all centered. You can figure that all blades are centered, but let's remove that, and let's discuss another option, which is merging rows. Here for the last two rows, you can figure that you have a narrow plate here or a tight plate, and you can make a vertical plates here. So we can do that by changing the orientation of the row to make it a vertical, and make the other one as a vertical. And by flipping them to vertical plates, you can make a merge between rows. So we merge those rows, and from here we can change the origin plate. As you can see, the origin plate takes orange color or brown color. So let's make it on the right like that, and make a split to the right. So we will get two plates here, and make another slip here. So we have 4 plates. So we can define each plate width here. So let's define the width of the origin plate to 1.5 meters, like that, and the same for that one, 1.5 meters. So we have those other plates here like that. The same thing we will do it here. Let's flip this the orientation of those rows to make them vertical, and let's merge those rows. And from here, let's define the make it half plate and define the width of this bottom plate like that. And you can add two other plates like that here and there, and define that one to be 1 meter 5 and that one 1 and 8. So you can control the arrangement of plates by that way. You can make an offset. For example, let's make it offset with half meter. So you can make the welding line offset like that, and you can make it centered. You can make it full size, sorry. And you can change the orientation of this one. So let's make it 100 like that. So you can change the orientation of plates by that way. Now let's change the orientation. Let's make it 0 and save that one. And let's start creating the assembly of the roof. As you can figure here, the assembly rendered during creation. Okay, now the assembly of the roof is done, and it will be automatically assembled with the tank assembly. Here we have the tank, bottom, shell courses, and roof. Now let's add some attachments here. Let's add a cover for the roof. So from here, let's define the thickness of the plate, the overlap, and the length. Let's add a cover, top cover plate, millimeters. The longitudinal building line orientation, let's make it 45. Save, and click on Start Assembly. Now, after generating this item, we will make the anchor chair, make a clean outdoor and some other nozzles, make a spiral stair, a platform with ladder, and some nozzles with internal piping and external piping. Okay, from here, let's select the first can. We will add anchor chair here. Okay, so let's select the first can. Okay, and from elements, let's add anchor chair. So from here, let's select. Okay. And for the anchor chair, you will find 3 different types. The traditional anchor chair from top plate, another one with top ring, and the third one for tilted bottom. If you have a tank with a tilted bottom, so the location of each anchor chair will be different. Okay, so each anchor chair you will generate it separately. Here for the anchor chair, let's you can add a wear plate if you have a wear plate as a reinforced bed for this anchor chair. But let's keep those dimensions as they are, and let's add a rectangular washer and the washer dimension, and let's have 12 anchor chairs. And here for the orientation, so let's calculate the orientation for 12 chairs, which will be 15 degrees. So let's add 15 degrees and click on Save. Now let's click Start to generate the anchor chairs. Okay, here we have that the front view and that welding line at 0 degree, and here we have the anchor chairs. If we take a look at one of them like that, so that's the anchor chair like that. Okay, now let's add a clean outdoor. So from here, let's select the first can, and from elements and from nozzles, let's select clean outdoor. And from, if you select the clean outdoor node from SEG, you will get this list. And each type of those with a different manway David or a clean outdoor David. Here for type A with small David for small sizes. A clean outdoor with that configuration. Another type of clean outdoor. Those types which we discuss here. Those types. Okay, let's select the type A. And from here you can select the size 8 by 16, 24 by 24. Let's select 24 by 24. And if you would like to make a change for the API dimensions, you can select user-defined dimensions, and from here you will be able to change the dimensions of the API. But let's keep it as they are. From here, if you have this clean outdoor on a different shell course, okay, you have a shell with, let's say, a thickness greater than the other plates. So you will define the difference between the shell courses here in that value. For the orientation, let's define the orientation as 30 degrees. Okay, and here's the materials, and let's click on save. And now let's click on start assembly to generate the clean outdoor. Here's the neck blade of the clean outdoor. The rebad. Flange first part. Flange second part. The gasket. The cover. Tightening bolts. Tightening nuts. The manway or the clean outdoor David. Okay, now we have the clean outdoor. Now let's add some other nozzles on this tank. Okay, so let's select the last can. Okay, and from here, let's select elements, and let's add another nozzle. Let's add nozzle 1. And for the nozzle 1, let's select a nozzle from pipe. You can figure that you have a large list of nozzles with the different types, as we discussed in this slide. You will find a nozzle from pipe, nozzle from plate, long weld neck nozzle, more than 23 types of nozzles. Let's add a nozzle from plate and select the size as 10 inches. Sorry, this nozzle according to as made. So let's delete it and add another nozzle according to the API. So you will be able to add a diamond pad and circular pad. So from here, let's add a shell nozzle according to API. So that's one. From here, let's select nozzle from pipe, select the size and select diamond pad. And from here, let's select the schedule of this pipe and define the location. Define the orientation. And for the projection from the outside diameter of the vessel, but let's define that after adding a flange. So let's add a flange here. Okay. And select welding raised face according to ASME B16.5. Rating, let's keep it 150. Select the size of the flange and the same schedule of the pipe. Okay. And if we come back to the nozzle again, from the calculator, you can calculate the projection of the nozzle. If you take a look to the image here, if you take a look at the image here, by defining the projection from the tank center line to the facing of the flange, SEG automatically will calculate the projection of the pipe, the required projection of the pipe. So let's make a new page. Some points here. We have this circle, which is the diameter of the tank, and that's the center line. And we need to make a nozzle projection here. So the inside diameter or the outside diameter here will be divided by 2. So that's the outside radius here at that point. And we need to make a projection over that value with one, let's say 200 millimeters. Okay. So the projection from center line, if we calculate it, so that's the projection to the facing of the flange. So let's make it 4 meters 750. So from here, if we come back here, 4 meters 750, sorry, and click calculate. So SEG will calculate automatically the projection of the pipe here, which is 140, and it will be reflected to the projection on that form here. It will be reflected. Okay. Another option for the set weld, here SEG detected that you have a rebad and a pipe. So you can, you have an option here to select a single V weld or a double V weld. So let's select a single V, and you can add a clad on the parent element or parent and nozzle, or you can make it without clad. Here you can define the fillet weld A, which is between nozzle and rebad. So let's make it 8, and the fillet weld between rebad and can. So let's make it 8, and let's click on save or section save. So 8, and click on save. Okay, now let's create this nozzle. So we have a 10 inches nozzle with a diamond rebad. After that, we will make an external piping for this nozzle. Okay, so to make a piping from the external connection of this nozzle, let's add some other items after this flange. So from here, let's add N1. Okay, so let's select according to ASME, select the size of the gasket. Let's add another flange. And let's make it looks like N1 flange, but we will flip the facing of this flange, so like that. Let's add a pipe, N1, and define the size of this pipe to be 10 inches with the schedule 40, with a length, let's say 1 meter, and let's say 50 millimeters right now, and click save. Let's add an elbow, N1 elbow, like that. Let's make it a long radius elbow, 10 inches. Select the schedule 40, and click on save. Now let's create those items. They will be connected to the this flange. So we have, if you take a look here, after finishing, I will show you that. We have connected piping to this nozzle here like that. We have another flange connected here, another pipe and elbow. And if you would like to flip the orientation of this elbow to make the pipe, connected pipe, goes below, so we can change the orientation of this elbow, make it 190 degrees, and let's add another pipe in 1, 2, and let's make it looks like in 1 pipe, 1, and let's change the length. Okay. And let's add an elbow, another elbow in, okay, and make it, and make the orientation at 0. And let's add a reducer, okay, in 1 reducer. And from here, let's select eccentric reducer, select the size which is 10 inches with the schedule 40, and it will be 10 by 8, and the schedule here will be 40, and the eccentric cone angle will be on 180 degrees, and click on save. Now let's click on start assembly. So the first thing, the elbow orientation will be changed. Okay, so you can figure that it comes to below. We have a pipe, another elbow. After that, we have eccentric reducer. Okay, so you have a piping, external piping connection here on the this nozzle. Now let's add another nozzle to the roof with internal projection. So from here, so here we discuss the nozzles with external projection and how we can make a piping for the external projection. Now let's select the roof, and from elements, let's add a nozzle with internal projection and external projection. So let's add N2. So you can figure in N2 you have internal connection and external connection. If you can figure that for this nozzle, we have external connection only for N1, but for N2 we have internal and external connection. That type of nozzle gives you the ability to make internal piping and external piping. You can connect to elements to the inlet of the nozzle and outlet of the nozzle. So from here, let's select the size of this nozzle, make it 4 inches nozzle with a schedule 40, and add a rebab, offset from vessel center line, and the orientation 190 degrees, and the projection from the weld line here. So let's make it millimeters, and the internal projection will, let's make it half meter. Click on save, and for the external, let's add a flange into flange 1, and let's make it slip-on flange. So let's select slip-on flange according to anatomy. Select the same size of the pipe, the offset of the nozzle from the pipe, and let's click on save. Now for the internal, let's select the internal node, and from here let's add another flange. So into flange 2, and make it slip on 4 inches and millimeters. Click on save. Now let's add a gasket. So from here, add in size. Add another flange. And make it looks like flange N2 flange 2. Okay, so it will be come here, and we will flip the direction of the facing. After that, let's add a pipe. So N2 And from here, select the size of the pipe to be 4 inches and change the schedule, define the length to be 5 meters, click save. And if let's take a section here on the tank to preview the, let's take a half section like that to check the nozzle during creation here. Okay, so let's click on Start Assembly. Here the roof nozzle will be generated with a rebad. Okay, so you can figure that this nozzle has internal and external projection. Okay, now we have this nozzle with internal projection like that. We have 2 slip-on flanges here and a connection point at the end here. If you would like to make another piping here to another place, you can make it by the same way which we did from minutes for this nozzle. Now let's add a spiral stair, okay, on this storage tank. So from here, let's select can 1, and from elements, let's select external attachment. And you can figure that you have a large list of the external attachments like a nameplate, external rebads, top davit for columns, grounding lugs, earthing bows, fireproofing clips, external stiffening, nozzle rips, many other attachments here. One of them is the spiral stair. So let's add. And let's make one level stair. So from here, you will find 2 different types. The first one is created completely in SEG library. And the second one here, that one of our customers asked us to generate that type of stairs, and our development team still developing this type. But right now, let's make this type of spiral here. Let's define the clearance between the spiral stair and the outside surface of the tank, the stringer thickness, the height of the stair, the stringer width, the stringer contact angle, the orientation, let's keep it at 0, the height at end of the stringer end cut, some dimensions, and you will find it related to the image on the right-hand side. The offset from the base, keep it at 0, stair inside width, which is the spacing between the internal stringer and the external stringer. The stair direction, we will make it counterclockwise. So if you take a look here, the stair will start at 0. So if you take a look from top here, so if you would like to make it on that direction, so let's make a print screen here. So if you would like to make the stair starts, sorry, if you would like to make the stair start on that direction, okay, that's clockwise direction, but in our case we will make it on we will make it on the other direction here, on the counterclockwise. So from here we will define it as a counter clockwise, and here the step width, the step thickness, the step rise, and here the channel size. We will keep all dimensions as a default. Here we will make a cut on the rails at the end of the start, so we will cut the rails to the first post here. It's not connected to another platform, so you will not select that one. Select this checkbox as a closed platform end. And from here, you can select the size of the post on the platform, define the number of posts on the spiral stair, 6 posts and 2 posts for that one, platform angle 12 degrees, and here for the reps dimensions, all of that. Okay. For the stiffening, for the bracing, here, for the bracing here for platform, back here with this image, we have stiff bracing here for the platform, so we can define the location and the activation of the required bracing. So from here we have the first one without bracing, which is at the bottom here, the first one here without bracing. Okay, and the second one we will activate it and change the location of this one, activate the third one with location. Okay, let's make it as like that, and let's add the last one like that, and let's click on save. Okay, I think that's okay, and click on save. Now we fill the dimensions of the spiral stair, and now we will start creating that element. And you can figure that each element will be generated and assembled on the spiral stair assembly. Okay, this model includes around, I think, more than 30 elements, so it will take some time to generate it, around a minute and a half or 2 minutes to generate the complete 3D model for the spiral stair. Here's the steps and the platform. UBN Commerce. Okay, any questions during the assembly of the spiral stair? We can discuss some points during the assembly.
Yeah. Mr. Ahmed, till this moment, I would say, can you hear me?
What?
Can you hear me?
Yes.
I was saying that like the demo till this moment is my one word would be that it's very impressive. Okay.
Alhamdulillah.
The work that you have done is like amazing, and it's like amazing. Okay, till the shell development was okay, but now you have a spiral stair also. So for me, it's really amazing. I just want to ask you, how long have you been working on this software, and how you came up with this idea of creating a 3D software for the static equipment?
Okay, since starting on working on this field on 28, I start working on that field, which is static equipment field. I found that there is a problem in generating the drawings of the equipment, and each time you will repeat drawing again. I started with AutoCAD, which is a traditional way for drawing. For example, when I start making an ellipsoidal head, I found each time I repeat the same orders, repeat the same sketch for the flange, all of that. I found it takes a huge time with each vessel. From this point, I started creating some parametric models by making a link between an Excel sheet with Autodesk Inventor. That's in 29. Start making a relationship between Autodesk Inventor and Excel sheets. Prepare the Excel sheets, which gives the dimension automatically. For example, if you would like to change a size of a flange, just from the Excel sheet, select the size, and automatically the dimensions will be sent to Autodesk Inventor. That's the first step on parametric modeling.
And that's in
After
2009?
that, what?
You're saying that was in year 2009?
Yes.
Okay, so it's almost.
After that, I made a lot of things by using that method for heat exchangers, pressure vessels, but I found it's still difficult. Okay, in 2013, I dealt with the iLogic. iLogic, it's a tool in Autodesk Inventor, gives you the ability to make a macro and programming on Autodesk Inventor itself. Okay, so I start from this point and create the first application for me, which is 3DBV. That's the first application that I developed. In 2016, I decided to prepare a team for a new application dealing with the Autodesk Inventor APIs directly, which is giving commands to Autodesk Inventor to generate the 3D model and drawings, make the things more professional and easier, by the way. So from 2016, we started developing SEG software. In March 2019, we developed the first release of SEG software. So the first release was March 2019. Okay, and it was including pressure vessels only. After 1 year, we include towers. Another 1 year, we include storage tanks and heat exchanger. And after 6 months, we add ducts and spherical tanks. So we cover a lot of, now we, alhamdulillah, we are covering many types of equipment. Okay, now we have this spiral stair, and if you would like to check if you have a clash, so you have the 3D model, so you can figure that the first bracing here, we need to decrease the height of this one a little bit to avoid clashing with the third step. Here, that's the third step, and you can figure that we have a clash here, so we can decrease the height. So in detail, you can decide what you can do. Here, for example, we have a rebad on a welding line, so you can minimize the location or increase the location of this one, that one also, so you can decide what you can do. Here we have that spiral stair in detail. Now let's add a platform as an to give you an access to make a repair for this nozzle. For example, we would like to add a platform here. So from here, let's select CAD 3, and for elements, let's select platform and select vertical platform. So platform. And from here, let's select a vertical platform with a defined angle. The second type was a complete platform like that. But in our case, we will not need that one. We will need the vertical platform. Let's define the clearance between the outside diameter of the field, platform width, the height of the platform, and the start angle. Let's make it at 45 degrees. And the contact angle, let's make it 50 degrees, and the location, let's make it on let's say millimeters, and let's click on save. Okay, let's add a ladder and change the ladder height, and let's add a cage for this ladder and click on save. Now let's create the assembly. Here you will find the location of the this platform. After creation, you will find the location of this platform need be to be flipped. So the location of the stair need to be on the other side. So how we can deal with that? By changing an option here and some parameters. You will, after creating the 3D model, you will get my point. Here you can figure that the axis of this platform may be not good. If you would like to flip the location of this stair to be on the other side, so we can change the start angle here to make it 95 and the contact angle keep it as it is. And here you can select the flipped to make the platform start from that angle up to that angle. So the location of the ladder will be on that side. Okay, so let's save that and let's click on it. So you can figure that the axis of the ladder will be here. If we measure the distance between the grating surface, so from tools, let's select the measure tool and let's measure from the grating top surface to the, let's say here for the bed, it's greater than the man length, human length. So we can decrease this value by changing the location of the platform. So let's come back to the platform, and for the location, let's increase it with half meter and start the assembly. As discussed on the presentation for the ladders and platforms, here let's come back here. The ladders and the platforms generated as a single part, so you will not get a detailed bill of material for it. You will get an information as you have a ladder, but not a detailed bill of material for that ladder. You will get a part as a platform, but not a detailed items for this platform. So let's check the bill of material here. If we open the bill of material table here and is that here, so let's check the ladder and platform. Here you have a ladder here, okay, and that's the length of the ladder. It's defined as a simply, not a detailed items for the ladder. The same for the platform. You have a platform, but not a detailed platform. You have a grating, okay, that's the only item with the description, okay. But for the spiral stair, you will get detailed items because, as you can figure, we generated as a separate part. If we open the spiral stair, you can figure that each item here. For example, if we open the internal stringer of this one, you will get this one. And if you would like to get the flat pattern, which is the shell development for this item as a blade, so you can figure you have a blade, the shell development for this item. Okay, so each blade here you can get a shell development for it.
Here now, since this on the stringer, you will have the stair threads with bolting, right? The connection will be bolting. So yes, you will have development bolting details, like the dimensions of bolt to bolt.
At that time, the option of bolts not available yet, but we are planning to add many other things for the storage tanks and shop. But right now it's not available.
Okay.
Okay. And you can make it if you would like to make it manually on the 3D model. On this 3D model, you can do it, but right now it's not automated. Okay. Okay. Here we have this platform, and let's add a platform clips. As we discussed here, for the platform clips or ladder clips, you will get it in detail. If you add it in SEG, you can get it in detail. So let's add platform clips here. So let's select CAN 3, and from external attachments, let's add a platform ellipse. So from here, so you will find a huge list of different types of clips. And from here, we can select the suitable type if you have a complete number of bracing like that. But in our case, we need to define a certain number, for the platform support. And from here, let's define the length, the UBN size, select the suitable size, the material of the UBN, and the location. Let's make it that right now. After that, we will measure the required length. Define the first angle, support angle size, start angle. It will be the start angle. It will be the start angle here. So let's make it 47, and the last angle, let's make it 3. And the number of supports required, we will add 3 supports under this platform. So one on the beginning, one at the end, and one on the middle. So let's add 3 supports. Bracing angle offset, which is dimension S at the beginning. Let's add a wear plate. So let's keep all dimensions as they are. If you would like to change the bracing angle size, the UBN size, click Save. After that, let's click on Start simply to start creating the platform support. Okay, now we have the stiffening or the bracing or platform clips. We need to change the location of this one to come below the platform. So from here to there, we need to minimize the location with 80 millimeters. So from here, let's come back and change this location and increase it 90 millimeters. Okay, inshallah, after this step, I will show you some general items in SEG software, like the external and internal attachments. If you would like to make a coil, inside, outside coil, and some other attachments for the main items. Like that, how you can deal with that. Here for the last one, I think the orientation of that one, we need to change it. So it should be on 90, so like that. And during the updating of that command, let's discuss some items here for CAD. For example, if we open the elements, here you will find a group for the supports. So you can add supports like support saddle, tilted saddle for tilted vessels, stacked saddle like which used in heat exchangers, support legs for the small size of vertical vessels, support lugs for engine vessels, skirts for vertical vessels, anchor chair for storage tanks, some other cradles for small type of vessels like air receivers and like that. Here for the nozzles, another group for nozzles, you will find the nozzles according to ASME with internal projection, another type with internal and external projection, Nozzles according to API with external projection, another type with internal and external projection, coupling, clean outdoor, weld outlets, stud outlets, and coupling nozzles. This type of coupling, you can make a connection to this coupling, but that one, it's in the coupling with a plug. But that one, you can make a piping and make another connections to this one. Another group for the lifting, you will find different type of lifting lugs and trunnions here. Another group for the external attachments, you can add a nameplates, top davit, and some other nozzle supports, platform supports, separate ladders, insulation, and spiral wing for the vertical and long vessels. Internal attachments like impingement baffles, deflectors, bundle retainer for heat exchanger, demister, stiffening, internal stiffening rings, cross beams, piping support and clad, and platforms here for horizontal vessels and vertical vessels, and coils and half pipe coils, internal or external. Now, after creating this one, okay, we will make we will make a drawing for that one. But before going to the drawing, let's check the tables here. Here we have a bill of material table, and in this table you will find a list of items. In this list you will find an item number, and this item number, here's the quantity for this item number. For example, we have a bottom plate with those dimensions, and we need 2 plates with that dimension, and the weight of those items will be like that. So you have a columns. Each column defines the item number, quantity, description of the item, and the technical characteristics of this item, the material of that item, and weight. Here for the part name, you will find the location of the item on your tree. For example, let's take a flange as an example. So here for this flange, for example, which is item number 26, here we have 3 flanges. Okay, they have the same technical characteristics, which NB is 4 and slip-on flange with the raised face class 150 with the same material, by the way. So the weight of the 3 flanges will be 16.6. Here you will find the location of this element in your tree. It's for N2 flange 2, for N2 flange 3, and for N2 flange 1. Okay, so here to detect the location of this element in your tree. So here a list of the elements of the tank. So you get a detailed bill of material for the tank. And here the total weight of this tank, it's 24.5 tons, around 24.5 tons for this equipment. So that's a list of the bill of material. By the way, you can export this bill of material. So we can export this, you can export this bill of material. So if we select the desktop and here tank bill of material, and let's click on save. Now it's exported to the desktop. If we come back to the desktop here, you will find this bill of material. If we open it, you can figure that you have an exported bill of material for this tank. So if one of your colleagues needs some information to prepare another study or something based on your information, he can use the exported Excel sheet as a beginning. Okay, now let's check. Yes.
So just one here. Now you have generated this bill of material. Okay. Is there a summary of the material, like BOQ? Like for example, can you open the Excel file again, please?
Yeah.
For example, if we see the plates, it's like 4 meter by 1.5 meter, 5.6 by 9.7. Now I need to purchase from the local market. The standard size will be 2 meter. I mean 1.5 by 6 meter length. So how is there a tool to generate the summary BOQ that we call?
No, but here, as discussed, you have a tool for nesting, which will give you a calculation for the required number of plates. Okay, let's make a test for something like that. For that bottom, let's open the bottom plate. Okay, we have those bottom plates, and let's create a nesting study. So from here, let's create a nesting study, and let's select the millimeter type. Okay, here SEG detect the material and thickness of the plates. And now start creating the shell development.
So the nesting will be automatically done. Nesting.
Yes, it's a separate tool in Autodesk Inventor. You can use it to make a nesting, but it will take some time. So I will show you a sample for that. And already we mentioned it on the video here.
Okay.
Okay, for that, like a nesting for bottom plates and like that. If you take a look to that, that's a roof and bottom plates. So you can make a nesting to calculate the required number of plates.
Okay, and it will give like a summary. So I think you're saying that for each part we'll have to do individual nesting. Like for example, we will have to select bottom plate and say give the command that do the nesting. It will generate individually.
Yes.
Okay. Not I can say one command for the whole tank, and I say give me nesting. It will. It's not possible.
Well, it takes a huge time, and you may get some errors because this tool, I think, has some limitations. It's an Autodesk tool. It's very good for nesting, but it's better to save time. It's better to make some items separately. So for roof, you can take the roof and make a nesting for the roof only. For the bottom, you can take the bottom only. And for the shell plates, I think it's easy. You have a complete plates and half plates, so you can calculate it. You will not need a nesting. But for rebads and other attachments like chair or something like that, if you would like to make a nesting, you can make a separate assembly for those items and make a nesting in one time. I will show you a sample for something like that. Bismillahirrahmanirrahim. We prepared it after that in something like that. You can figure that you can get the nesting by that way. Okay. Bismillah. Now let's discuss some other tables here. If you have a couplings in your model, you will get a list of couplings. If you have a nozzle load, if you have a nozzle load like forces of the piping reflected to the tank, if you would like to include it as a table in your drawings, you can do that. I will show you how to make something like that. For example, for N1, if you would like to add some loads to this nozzle, like radial force, tangential force, all of that, if you would like to add some forces, some moments, and click on Run. Now, if you open the nozzle load, you will find a list of the nozzle load in the nozzle load table, and you can export this table to your drawings. For example, here for the roof nozzle, or if you have nozzles here, you can add that. For the nozzle table, you can figure that this table includes all nozzles in your model. We have a clean outdoor, we have full openings, we have a clean outdoor, nozzle N1 and the nozzle N2. Here's the service of the nozzle, the size of the nozzle, the outside diameter, the orientation, the thickness of the nozzle, the scalable. If you have a connected flange, the flange type, we have a Wildenich flange, and here we have a slip-on flange. The facing of the flange, that's a flat face, that's a raised face. The same if you have a blind, the facing of the blind, the projection of the nozzle, and the welding style. Here, that's the welding style. We defined it for nozzle N1, so you can define it here. Okay. Another table for flanges, if you have flanges, so you have a separate table of flanges. Table for gaskets, table for fittings. If you have like that, we have a eccentric reducer. We have 2 elbows, so you will have a list of fittings. You have a list of pipes in your model and a list of nozzle orientation. So each orientation for each nozzle will appear here, and a material list for the roof and the bottom plates, the seamless pipe materials, okay, for support plates and gaskets, flanges, all of that. Okay. Now let's preparing the drawings from the assembly. If you would like to define template, your reference template, you can import it to SEG as a reference template. So if you have a template in IDW extension, you can import it and define the name of this template, define the sizes as mentioned here on this image. After that, you can use this drawing as a reference drawing. Sorry. We didn't generate that. Okay. Now, after updating this one, let's generate the general arrangement drawing and a bottom detailed drawing for the bottom plates and how we can deal with that.
Mr. Ahmed, here just one thing. Yes. On the bottom plate, can we add a sump?
Yes, inshallah. We will do it after the assembly. Yes, here I need to change that value. Sorry. Okay, so let's make it 27. It's okay. Okay, so let's select the bottom from here. Okay, and from elements, you will be able to add a connection or a nozzle opening to this one. So from here, let's add a sump. And for this sump, you can select from different types. If you have a nozzle connected, nozzle from pipe, nozzle from plate, long Wildenich nozzle, forged hub nozzle. So in our case, let's select a nozzle from plate. Okay, and let's define the outside diameter of this one as 600 millimeters.
Can it be a rectangular? A rectangular sump?
No, for that case, it's circular sump only, from pipe or from plate or as a forged.
So you have an option for some, but it can be only circular.
Circular, yes. If you would like to add another option for rectangular, our technical team offers that for free for our customers. If you have any request and if you would like to add new items to SEG, you can raise up your request and our team can do that for free, inshallah. But we will need some information from you. For example, if you have a standard spec or standard dimensions, you will send your spec or your standard or a sketch. After that, our development team, if we have any questions, we will come back to you to generate this item and include it in SEG library, inshallah. We already did a lot of things for our customers like that. Here, for example, I will show something here, but let's finish this one. Here, so for this sump, if we take a look to the bottom, here, if we take a look to the top and flip this view. So we can add the sum on 90 degree or 190 degree, or with an offset, so to avoid the welding line here. So let's change the selected thickness, the longitudinal welding line orientation, the gap, the offset from within center line, orientation, material, and here that projection, and make it sit in or sit on. So let's make it sit in, and let's add a rebad. Okay, so let's define rebad and rebad thickness, and let's click save. And from here, let's add an end blade to this one. So let's select end blade. From here, you can select between rectangular and, in our case, we will select a circular flat end without holes, and the outside diameter at 40 with a thickness 3 millimeters, and let's click on save. Now let's start the assembly. So it's a front blade with a reinforced rebad. Okay, so we have here the sum on the bottom like that, and let's add a nozzle at 90 degrees, okay, 2 inches, with an internal deep pipe to this sum. Okay, so from here, okay.
Mr. I think it's okay. We got that it's possible. So can we now proceed for the detailed drawing, please? So
Okay.
that so as to save the time.
Okay. Here, before proceeding with this, okay. Let's proceed with the drawings. From here, you can select the equipment from the tree, the equipment node from tree, from SEG tree, and by clicking on it, right click. From here, you can select drawings and create a drawing for this equipment. From here, you will get this dialog box, and from this dialog box, you can select from the first tab, which is sheet data. You can select the sheet size. Let's make it A1. Okay, and here the dimensions of the drawing. You can change the location of the title block. Okay, it's as a default on the right bottom, and you can make it as a landscape or portrait. It's actually 90% it's a landscape drawing. So from here, from the active views, we will select the required number of views in our drawing. So let's select the elevation view. We will make a one view, and the other view, which is top view, we will create it and change the location of it by hand, or you can make a bottom view like that, or a top view for like that. Select the required views from here and define the spacing. But right now, let's select the elevation view, and from here, let's select the orientation view. So the orientation view, we will make it from the back view, so that will be the elevation view, or you can make it like that to be the front view, so that will be the front view of the drawing. So from here, we can select the front view as the elevation view and define the location of this view on the drawing. Define the scale. Let's make it 1/40, and we will change those dimensions, which is the X and Y and the scale, after creating the drawing, to check the size of this view inside the drawing and the location. Okay, from tables, let's select the bill of material table. Okay, if you would like to include the design data table, we can include it. The nozzle table and the maximum allowable nozzle load table. And from the notes, if you would like to include notes, edit, that's a default notes. If you would like to delete them or import notes from an external Excel sheet, you can do that. And for the welding details, you will get this library of welding details. So, for example, you will find some default selections. Here we have a single V for shell welding, longitudinal welding lines, long weld neck nozzle, and we have an elbow detail and slip-on flange weld. We have a nozzle with a rebad, like that one. All of nozzles with a rebad. Okay, clad nozzles. We have some attachments like that. And for here, let's add the detail for the overlap. And if we have an annular plate, you can add a detail like that. So let's add details like that. And from here, shell, the first shell course with the second shell. So let's add this one. And let's click on save. Now, if you would like to add a client document list, like if you have mechanical data sheets that you received it from client, or another data sheets you received from the client or specs, you can add it like mechanical sheet and give it a number like that, so you can add it. Or if you would like to edit, so you will get the data here and you can save it. For the vessel document list, if you have some drawings like bottom plate, for example, bottom plate scale, like that, and give it a number, WG, like that, and add it. Shell plate development, like that, you can add your documents, mechanical calculation, all of that, you can add it in this list. Okay, now for the title block for this drawing, it's a general arrangement drawing. And the drawing number, WG. And here's the revision table, so we can edit on this table. It's revision 0. The checker and prepared by. You can add some empty cells if you would like to add. And for the design style, here you will get an option for defining the required number of sheets per this drawing. Okay, I will show you an example for that. For example, for this drawing, you have a lot of information here on this drawing and no place for the bill of material. In that case, you can separate it on a different sheet like that. So you can add the bill of material on a separate sheet. So you will have sheet 1 of 2 and 2 of 2. And if you have more sheets, you can increase the number of sheets to add other details to the same sheet. Okay, so from here, you can define the required number of sheets. So let's select the design one. And if you would like to move, for example, the bill of material to another sheet, you can move it from here, but you should select 2 sheets to be able to move this one to another sheet. Now let's select save and select create drawings. Now SEG will proceed with creating the general arrangement drawing for this tank like that. Here you will get the revision table. Here that's the bill of material table, automatically filled with the values. After that, it will be takes place on the drawing, the correct place on the drawing. And you can imagine how much time you will take to prepare a bill of material for a tank like this. Here in minutes or seconds, you will get a detailed bill of material. Here, the design data table and the bill of material. As we discussed, if you have a huge number of details or information, you may need to separate some tables in another sheet, like in that case. But I think for this tank, the design data table, we can decrease the values of that one because it's not like pressure vessels. In pressure vessels, we need a lot of information for the design code, the maximum allowable working pressure, the seismic and wind code, a lot of things like testing of the material for shell, nozzle, all of that. But here we can make a modification to decrease the number of values in the design data, and we will reflect it again to the drawing. Here you can figure that the welding details takes place in the drawing. Okay. Okay, now we done. The location of this view, we may need to change it a little bit, change the X location. So if we take a print screen here and come back to the notepad. Screen. And here. So that's the location of the view. So we can define the location from here to there. So we need to change the Y location and the X location a little bit and increase the scale of this view. As we discussed, let's come back to the drawing form again. All of data are already stored. The check boxes on the tables, the revision table, all of that already saved. Here, let's minimize the location on the X direction a little bit. So we will decrease it with 5 centimeters. And for the Y direction, let's increase it another, let's make it 25 and decrease the scale a little bit. Let's make it 32, for example, and let's update the drawing. Okay, so we have that the location in X and Y. So we may change it a little bit. And if you would like to change it by hand, you can do that. But any change from the form will be reflected again to the drawing. Okay, now let's make a top view for this one. So that's the top view, and let's break the relation between it with the other view. Okay, and let's rotate it. Okay, like that. Change the scale. And move it another place on the drawing, like that. So we have the top view here for this equipment. And here you can add the orientation for nozzles. For example, if you would like to add a notification for the clean outdoor, so let's add a center line for this clean outdoor. And from here, from balance, let's select a nozzle tag. So if we select this one, select parts only. So we can get the balloon of this nozzle. So that one is a clean outdoor. And for this nozzle, let's add a balloon for this one. So that one is nozzle N1. Okay, and for that one, it's nozzle N2 at the top. Okay, so let's add a center line. Here, so we have this center line for this top, and the location of the spiral stair starts at 0 and ends here. So you can define the elevation of nozzles, for example, like that. So that's the location. Let's define the datum point, which will be the top of the base plate. And let's click continue. So that's the location of this nozzle. And if you would like to define the balloon of this one, so let's select the balloon, and from here you will get the location and the balloon for this one. You can define the length of plates. So that's the first course length, second, third one, and the last one. Okay, and if you would like to add some other standard blocks like north orientation, you will find the list of standard blocks here for the welding and for another details. Here for the north direction, for example, you can add the north direction like that, or if you would like to add it by another sample like that, the north direction. If you would like to rotate it, for example, like that, we need to rotate that one, so we will make an edit. So by double clicking on it, you can change the orientation of this one. So let's make it on 45 degrees. So change the orientation of this one like that. And for the outside slope, to define the slope of this one, you can define the slope A and B. It's 1 to 5. Some other tables like weights table, if you would like to define the weight, so the empty weight, let's make it 24.5 like that. The erection weight, rating weight, hydro test weight, like that. So you can fill the weight summary. You will find a lot of tables here like a foundation load, so you can add a foundation load. If you would like to get the center of gravity for this one, so from here let's select this assembly and get the actual center of gravity for this one. So by clicking on center of gravity, you will get the center of gravity here, this one, and you can add this notification here. And if you would like to find the offset or the location from the data line, so that's the CG, so it's that's the center of gravity in case of empty. Okay, now you have that one. For example, if you would like to make an editing for one of those tables, like we need to modify the design data table, for example, and reflect that on bill of material, and let's add another nozzle and reflect that on the nozzle table and the maximum allowable nozzle load. Okay, so from here, let's go to the design data table here, and let's select all and remove all checkboxes, and let's keep some data only here, not all data. Let's keep some of them and click save. Okay, now we have those items only. They will be exported to the drawing. And for the can number 4, let's add another nozzle. So from here, let's add N. And this nozzle will be, let's make a manhole with a davit, for example. So from here, let's select a nozzle from pipe, select 24 inches with a rebad, define the rebad width, and select the schedule, define the location, the orientation, and here that's the projection. Let's calculate it. It's a man way. And let's click on save. Let's add a flange here. So from here, let's add a flange in 3. Okay, so we have this flange as me with 24 inches and schedule 40. And let's click on save. Now you will find that we have new 3 items on the bill of material. We have a pipe for the nozzle neck. We have a rebad. We have a flange with 24 inches. Those are new items in the bill of material. So if we open the bill of material here and take a look to the required number, the number of items here, it's 305. But on the drawing, let's move this design data out right now. You can find it's 302. So we have 3 different items increased. Okay. And we get a new nozzle here, which is nozzle N3. Okay, so if you check the bill of material here on SEG, you will find the new items. Let's check the nozzles. For the flange, for example, you have a new flange here, which is takes item 26, and here that is the size 24 inches, weld neck, raised face with class and scalable like that. Okay, so let's create this item. So from assemblies, let's create this nozzle, and before creating, let's add a nozzle load here. So let's add a nozzle load. This one. So if you check the nozzle table, you will find the nozzle N3 appear here, which is the manway, and for the nozzle load, you have a new nozzle which is N3. So let's create the assembly for those elements. After that, we will check how we can reflect that to the drawing to update the bill of material, design data table, nozzle table, and the nozzle load table. So we have 4 tables we need to update. Okay, here we have this nozzle.
Yeah, just one thing. For the flange of the manway that you have made, it was like a standard flange. Can we put API 650 flanges?
Yes. Okay. So from here, if we go to the flange of this nozzle, which is N3, you will find the list of standard flanges like long weld neck, raised face flange, long weld neck with RTJ flange, slip-on threaded lab ASME, and if you come below here, you will find a API standard flange or a user-defined API standard flange. So you can select the suitable type for your case. Here it's 24, and you can define the thickness. So let's make it 10 millimeters thickness for this one, and click on Start to update this flange. So here from the list, you will find the standard types on the standard flanges. Here, if you select the external connection here, you can define flanges, which is they are standard flanges. Okay. In case of using the overall module, you will find another element which is designed flanges. Actually, we are using it on the heat exchangers because all flanges shall be designed. The thickness, bolt circle diameter, outside them, all of that is designed on the design tool like BVLit or Compress for the heat exchangers. So you will find another element here called the designed flanges. So in designed flanges, a lot of options available if you would like to define a flange from scratch. Okay. Okay. So here, after creating this flange like that, okay, let's update the bill of material and design data table. So from here, from drawings, let's select create drawing, and from tables annotation, let's keep the required tables only. We need to update the bill of material, design data, nozzle load, and maximum allowable nozzle load. We need to select this checkbox, which is update tables automatically. If you select this checkbox, SEG will update the selected tables. So if you click on create drawing, as we discussed, the location of the view will be changed because we changed it manually, that view. And you consider that the bill of material table, now it's updated. All information inside it will be removed and refilled again. The same for the other tables. The other selected tables, which is they are bill of material, design data, nozzle table, and the nozzle load. Here, that's the design data table updated. Now the nozzle table. After that, the nozzle load table. Now we have all tables updated, and you can figure that nozzle N3 now included here, and for the maximum allowable nozzle load is included here. We can move this view again to that location. If you would like to add another block like nozzle load on shell, from the standard blocks here, you will find a list of standard blocks here on SEG. You can select for your case and include it. For the nozzle, for the bill of material, let's move it a little bit over the revision table. Here, so if you check the number of elements, you will get the same number here. And for the item number of the flange, which was 26 here, that's 26, it's a flange. According to it's the size 24, outside diameter according to the API, and the agenda rakam kaza. Here's the material and weight of this item. Okay, one more option, how to reflect the item number and balance to the elements. Here, for if you select the item number and the balance from here, you can figure that this balance is empty. And here, if you would like to reflect the number of the item number, let's open the bill of material to show you what I mean by that item number. Here, for example, for this shell course, for example, it takes item number 18, okay, and that one it's 19 and 20. So to reflect this number to the bill of material or the drawing, you will need to make an update item number from the assembly tab. You will need to click on the update item number. This process may take between, it depends on the number of elements. Here we have 300 elements, so it's around between 3 and 5 seconds for each element. So it may take between 4 or 5 minutes to update this item number. But I am telling you how to make that by clicking on this button, and the all balance, if you add a balance, it will be reflected. So let's show you that, for example, here the balance here will be filled automatically for the item number. If we back to the drawing on that sheet, so the balance will be filled with the values identical with the bill of material. Okay, by that way, which is clicking on update item number, you will be able to do that. Now let's create a detailed drawing for the bottom. So how to do that? So from bottom plate, let's select the bottom plate, and from here let's select drawing, and from here let's select create drawing. Select the drawing size, let's select A2, and from active views, let's select one view. We need a top view only, and from here let's check which view we will need to make a drawing for the bottom. So let's open the bottom, and from here let's select the front view. So from here, that's the elevation view, that will be the elevation view. So from here let's select the here it's the front, so from here let's select front and define the location and orientation, define the scale. So let's make the scale 50 right now. After that we can change it. So let's remove all the checkboxes and let's add the bill of material. We will need a bill of material for the bottom only, and from here and the revision table 0. Save. Let's add some other empty rows, and from here let's select our single sheet and click on save. Now let's create the drawing. So the drawing will be generated like that, and here a list of the bill of material. Okay, so if you select a balloon for each one. So let's measure the dimensions here. So that's the bottom, and that's that plate, and here's the overlap of the plates. Here, let's add a center line. Let's change the scale a little bit. So from here, let's come back to that one and edit the drawing. Here's the drawing, and from here, let's change the scale. Let's make it 42, and let's okay. So the scale of this drawing changed like that. So if you would like to define the dimensions like that, you can do it easily. The width of each plate here. If you would like to add balance, so item, as we discussed, we will need to make an update item number. If you would like to make it now, we can do it, but it will take around 5 minutes to generate. If you would like to wait until updating, and during that we can discuss questions, we can do. What do you think?
We can skip this part of identifying. Can you show how you will generate like each part detailing
for this one, for this bottom?
Yeah, for this bottom.
For that plate, for example, if you would like to add it on a detail like that, we open it in a separate one, so you can control the scale 1, 2, 10, 20, 10. Okay, and now you can define it in and radius. Another one, let's add the top plate. Let's close this one, and from here let's open that one, for example. So if you would like to include it on the drawing, it will be like that. Let's move it here. Let's move this view. So in seconds you can get that, and you can add a balloon for the bill of material. So here let's add item number on the bill of material to identify that item. So after updating the item number, you will get the correct item number here as per the drawing here, the item number here.
Okay.
And here, as you can see, here you have a separate bill of material for the bottom plate. You have all bottom plates here, and dimensions, materials, and weight. And here's the total weight of the bottom plates.
Okay, if these item numbers, can we do manual numbering in the table in the SEG software, so that like we have some unique kind of numbering?
Like what? Because the manual numbering not matches with SEG criteria. Here in SEG software, if you have two identical items or some identical items, like they have the same description, they have the same technical characteristics, they have the same material, they have the same weight, so they are identical. Okay, like flanges. If you have 4 inches flange with a rating 150, the same schedule, the same material, all of that. So SEG will detect that they are identical, and the SEG will give them the same item number, like that. Here we open the bill of material here, for example, for flanges. Let's take a big screen and come back here. That for the flanges, let's take this part here. You can figure that we have 3 identical items. They have the same description, which is a flange. They have the same technical characteristics, which is NBS4 and slip-on raised face, the same class, the same material, and the same weight. So they will take the same item number. No way to change it. If you would like to make that manual, we don't recommend it. But there is a way to do that. Actually, we don't recommend that because you will lose the link between numbering in SEG and your drawings. Here, after exporting this Excel sheet, you will get an exported Excel sheet, which is that one. Okay, as we discussed, you can change the numbering of items here. After changing the numbering here, you can import this table inside your drawing again. Okay, let's take an instance from that table. Sorry. Let's close this one, and let's take and let's remove those columns. Okay, let's delete those and delete some items from here to there.
Mr. Ahmed, we cannot see your screen. Okay, now we can see.
Yes. Okay, so let's change the numbering like 100. And let's change the numbering. Okay, now we have a new bill of material. If you'd like to import this one to your drawing, so from here you can import a table, general table, and you can make a link between it with another table, like a copy from that one. So the started data will start from A0, and you can import this table to your drawing. After that, you can change the width of each cell, all of that. You can deal with that one. Like, for example, if you would like to increase the width of that one, change the width of those. Okay, 25. Make the formatting of the cell to be the left like that. So click Save. Now you can import a table from Excel, and now you can edit on it on the external Excel sheet. By that way, you can make your numbering. After that, if you would like to reflect this number to the item, you can do that from modifying the title of this one. Like, for example, this item is 105, so you can fill this value here, and if you come back to the drawing, you will find this value reflected to the bill of material. Okay?
Okay, Mr. Ahmed. We got it.
Any other questions?
I think it should. Sorry? Hello?
Any questions?
Yeah. There's like, for example, now this is a revision A drawing.
Yes.
Okay, now we made some changes in the drawing, and like, for example, the first part was split into two. Okay, the top bottom portion that you are seeing was split into two parts. Okay, so okay, that part number shall change, but it should not affect the other part mark numbering, right?
It will change the part numbering, because here in SEG we based on the group number each. For example, for the formed heads, if we have a formed head like ellipsoidal head, or spherical head, something like that, we give it a group number in SEG database. Okay, for the shell plates, we give it a group number, another group number for plates. For pipes, they have another group number. Okay, for bottom plates, roof plates, they have another group number. So the group number is the main the numbering based on that group number. So if we have a new item on the formed heads or for bottom plates or roof plates, so the numbering will increase. For example, Here, if we open the bill of material, now we have this plate split, and they have a new item. So we will get item number 6 here for the bottom plate, and after that we will start with the roof plates, because roof plates, they have another group number. So the roof plates will start from 7 after modifying. Okay.
Mr. Ahmed, I think you can have some modification in your algorithm. Like the new plate that we added shall have the last number of the plate, so that we don't disturb the current numbering in revision A, and in the next revision, if we have to go and if we are changing the bottom plate, it should have like the last number in the sequence, so that we are not disturbing other item numbers.
Okay, but here everything is matching, the bill of material and the item number. So if you check the bill of material with the item number, they will be matched. So
no, okay, matching.
I know, I understand your point, but here for making something like that, we should have a history for each element. Okay, if it's created, updated, changed or not. So it will be a headache for for many things to store each information for each element, because sometimes you may by mistake click on save here, for example. If you select this element by mistake, you may click save without changing anything. Okay, so now SEG will detect that there is a change takes place, and will make a loop to check where is the change and store it on the memory. And from revision to another revision, you should have the previous history. So all of that needs, you know what I mean? To store each information in each update, in each revision. So it will be a headache.
Okay, I will explain you our concern as a tank fabricator. Can you go to the list that we were seeing for the bottom plate? I mean the Excel file.
Yes.
Okay. Now let's say that we are following your sequence only. Can you go to the left side so we can see the left of the sheet? Okay, now if we are following the SEG item mark numbers, and in the revision A, the sixth, in the revision A of the drawings, we have cut the roof plate, which is item number 6, 7, 8, 9, 10. Okay, now I have a revision in my bottom plate in part number 5. It is split into two parts, so that so now if you make this part 5 and it's split and you give a number like 5 and 6, and the roof plate numbers are disturbed, that means I will have some problem in my drawings and the parts that are already cut. So for us, we cannot change the part mark numbers.
I completely understand what you are talking about, and I am trying to clarify why we didn't go with that way, which is keeping each information for a change for the element stored in history. I am completely understand what you are talking about, but right now something like that to make it from SEG itself, we may need a big plan from our team to discuss something like that and how we can do it. But as mentioned, if you would like to make this arrangement by hand, you have the Excel sheet, and I show you how you can make that, how you can export, and if you would like to edit, you can do that. But as discussed, it's not recommended. But if you would like to go with that way, you can do. Some other companies, for nozzles, for example, they give, if you have 2 identical nozzles with the same flanges, same pipe, same rebad, they give each item a separate part number.
Okay.
How? They do that, but in SEG, SEG deals with the identical item. So SEG will give the same flanges the same item number, the same pipes the same item number, and for rebads the same item number if they are identical. So if you working with this procedure by giving an item number for each element, that's an option in SEG. It's not an option in SEG. Because SEG deals with the, as mentioned, will compare the items and give the identical items and give them the same item number, and that item number based on the group number, which is on the database, the classification of each element. If it's a formed head, it's a plate, it's a bottom plate, roof plate, it's a nozzle, forged hub, it's okay. That's
Mr. Ahmed, I think it's a very, I mean, it's a requirement from our side, and hopefully in future you can deal with. For me, compared to the complex things that you have done, it's a very minor thing. I think hopefully it can be done. It can be dealt easily. Okay, we can move to other items. Now. Okay, I think I will just take 2 minutes to show our drawing and our tank, which basically for which we are looking for this software. Okay, I will present my screen to show you.
I will stop sharing my screen first. Stop sharing. Okay, now I think, dear Debek, can you give the accessibility for Mr. Misbah? To show his screen?
He can share his screen, no problem.
Okay.
Okay, I will share my screen. Okay, are you able to see screen?
Yes, sir. We can see your screen, sir. Yes, you can see your screen.
Okay, Mr. Ahmed, see, this is basically a typical tank that we have, like side erected tank, almost like 60-meter dia tank, 18.5 meter height, and we have a dome roof, and all this accessories are from aluminum dome roof supplier. The below part, all the steel item is our scope of supply. Okay, you have like a rectangular sump, a circular sumps, manhole cleaner door with a thick base plate, and then you have inlet nozzle with external, downcomer pipe, internal downcomer pipe. But inlet nozzle, you see that there is an elbow going upward, and then there is like 180-degree elbow, and then it comes down.
Okay.
This is inlet nozzle, and then you have overflow nozzle, pretty simple, like going down, but maybe with a gearbox inside.
Okay.
Okay, and then we have a walkway, like plate fabricated walkway. It's like a 1.1 meter width and 120 as a toe plate. And then we'll have a platform supports all around the tank. You can see this way.
Mm-hmm. I cannot hear your voice.
Okay, Ken. No, I was not speaking because there was.
Okay.
At the back. Okay, now you can see there will be wind girder. Okay, 1 or 2 depending on the tank height. So plate fabricated wind girder, almost 250 by 210. Okay, and then we will have kind of shoe plates. This is like a 500, almost like 500 by 500 plate. Width 500, length 500 plate. So that this is called a shoe plate, on which the aluminum dome roof shoes will come and sit. And a typical stiffener. Okay. And then see the plan view. I was asking you for this rectangular sum. Okay.
Okay. Here for this type of dome roof, it's not included in SEG. This type from segments like that, from aluminum parts, this type is not included. But our development team can develop something like that if we have the enough information, like how we can arrange those plates, the parameters used to calculate the number and define the arrangement of those rectangles on the beam roof. If we have an information for something like that, SEG development team can, inshallah, can development something like that. For the wind girder, it's available in SEG software.
Okay.
For the rectangular opening for some systems, it's not included. For the external piping, like you mentioned on the previous drawing, it's included. And for the pipe supports, it's included. But if you have a configuration for the pipe supports not included in SEG, inshallah, our development team can provide it.
Okay. Okay. Here for the aluminium dome roof, actually, this is not our scope as a tank manufacturer. It will be
but
coming.
I think you will need to make it appear on the drawing at least.
Just an appearance would be enough. We don't have to match exactly to the ADR drawing. Just like if you see this aluminium dome roof also, I mean, if you see this drawing, it's just a representation only. It's just a representation, not exact figures. Okay. This is related with aluminium dome roof. Now I was showing you this walkway.
Yes. For the walkway, part of it can be done right now, but the external part, it's not included yet. It's not included in SEG right now. The dome roof stairs are not included in SEG.
It's okay. It's okay. There's one thing I want to ask. For example, now we are usually working in the AutoCAD. Now, for example, with SEG, we develop the plan view and we don't see the aluminium dome roof. Now, from the AutoCAD, can I import to Inventor and just copy the top view of dome roof as a representation? Is this possible?
Okay, if it's not in detail, we can make something created in SEG software, but not in detail. We'll give you the same result.
Okay.
But actually here I'm asking if you would like to get a bill of material, detailed bill of material for each segment. In that case, we need to know more about this roof. Okay.
No.
But if it's just a shape, inshallah, we can make something like that. Give you some options to define the number of plates, the difference between each circle and the previous circle, so we can make a sketch, give you the same result. Inshallah.
Okay. Mr. Ahmed, if you can see, it's a typical walkway. Okay, but when the stair comes up, there is an opening in the walkway that we need to create. If you can see view. So I think you said the walkway will be just a representation and the walkway drawings are not generated. This is correct understanding? Or
the walkway is not included, but the spiral stair, if you have a spiral stair up to top with different levels, you can do it. The walkway is not included in SEG.
Okay, so I think you are developing that module and like it's in the development stage for the walkway.
No, we haven't an information or drawings from one of our customers. If you would like to submit something to our development team some standard configurations, inshallah we can do something like that.
Okay,
but right now it's not included.
Okay, I will show you. For example, just to show bottom plate also. Okay, this is our typical bottom plate. I think you are having also the same, but due to the rectangular sum, we will have some disturbances in the layout. Okay, and like mostly we go for annular with a like polygon types annular plate.
Okay, give me a chance to define to tell you something here. If you zoom to plate number BP29 and BP16 in that area, yes, here in SEG we haven't an option to make a plate like those plates, because you can merge rows, but all plates will get on the same direction. You know what I mean?
Okay. Okay, so
this option is not available to make a plate. Yes.
Here you're saying, okay, this BP29, BP16 will not be possible.
Yes, because we have two rows, so the rows will come to the end.
Okay. Okay. So then in that case, can we do some manual changes in the inventor?
Yes, you can do manual changes, but as you know, the in SEG will save time for you to make those things. If you try to make it by hand, it may take huge time from you. If you, for example, for each plate of those, if you would like to draw it and assemble it manually, you may take 3 or 4 hours to generate a bottom plate like that on Autodesk Inventor. But in SEG you will generate it in minutes.
Okay.
So you can make it by hand. Everything you can, because that's the reason to use a CAD software as a platform, because the CAD software, with the CAD software you have no limits. You can do anything. If you haven't something in SEG software, you can generate it and create it by the CAD software and import it to your model and import it to SEG library. Okay, bill of material. So you can make anything.
Okay.
By using the CAD software.
Okay, got it. This is like a typical sump drawing. I mean, it will be a rectangular on the top view, but there is some kind of a slope on one side. Okay, so I think in future you can add this in your modules. Okay,
yes, if we have a detailed sketch like that, inshallah, our development team can do it.
Show you our walkway. Okay, if you can see this walkway, this is like a typical, I mean, the top view of the walkway. And this is like a typical segment of the walkway. Okay, and you have this WPS-1 supports, which is at the shoe location of aluminum dome roof, and then you have simple walkway support at the, I mean, at the center of each aluminum dome roof. For example, what I mean is, like, for example, if you see this at this location, there is a walkway. The squares that you see, it's the location of, it's the location of aluminum dome roof support. Okay, this is another aluminum dome roof support, and then the middle we just have a simple walkway support. Okay, this is at the aluminum dome roof shoe location. This is the walkway support between two area shoe locations. So, and then you have on the this is the shoe plate that I was saying. It's almost like 500 by 500 plate, and you have 2 stiffeners inside the tank and 2 stiffeners outside the tank. Okay, this is a typical walkway segment. Okay, a typical walkway segment means, for example, this will be a typical walkway segment. Okay, and this will be repeated.
Yes.
Okay, and then we will have an opening in the walkway to allow access for the stair.
Yes.
Okay, and then this portion will be something different, something like this.
Great.
Okay, so
if we have a chance to get a detailed drawings like that, inshallah we can proceed with that and include it in SEG library.
okay, sure. We can do this activity in future. Okay, and then like we have typical handrail. I think it would be simple for you to adapt this in SEG. Okay, and then okay, it's just cage ladder fall protection. Plus, I think that's it. Do we have anything else? Okay. Now, how do we start? If we want this software, what's the procedure? How can we start now?
You would like to try it?
Yeah, we would like to try.
I think
instantly.
you tried, sir, right?
Huh?
I think you already tried, right?
No. Actually, I haven't tried it. It's the pressure vessel team. They have tried, but from tank perspective, we haven't tried it. So we want to try it instantly, and then very soon we want to proceed for actual software. So can maybe Deepak or Mr. Ahmed, can you define what's the procedure?
Okay, I think inshallah Mr. Deepak can send you the download link for the application. You will need to have Autodesk Inventor in your machine, so you can use it as a platform. After installing SEG software, you will make a registration, and I will show you a video for registration. Here, Bismillahirrahmanirrahim.
This procedure I have already explained to Mr. Jalal Alam.
Okay. If you have already discussed with Zara, okay,
yes, we can. You know the procedure.
We can discuss with Zara. Okay. Regarding the actual this software SEG software we will download from your link. What about Autodesk Inventor software? That also will come from your link, or it will be a separate link?
No. That you can search on the Google, sir.
You can download it from Autodesk website itself. You will find a link for downloading, and it will give you 30 days for free.
Okay. Now, can we know what's the price for this software? How it will be?
The price also I have sent to Mr. Gerard, almost 15 days before, sir.
Sorry?
I'm saying the price is already sent to Mr. Gerard. The proposal I already sent to Mr. Gerard, sir.
Okay. I will check with Zara on this.
Yes, sir. So, yes.
And we will have to buy Autodesk Inventor as a separate software, right?
Yes, sir. You need to buy, sir, because this Autodesk is SEG CAD software. It is working on top of Inventor. So Inventor you need in the background, sir.
Okay.
That you need to buy separately, because yes, that you can buy somebody from in Saudi Arabia. They have a lot of he knows that your IT person. He knows that who is the dealer for Autodesk.
Okay, I will check with Zara on this. And Mr. Ahmed, here now, if we go for a demo version or a purchase of this software, will you be giving our team some kind of training for a short time?
Yes, there is a training on SEG software for 5 or 8 hours for free.
Okay.
After that, if you would like to make a training for some real cases or a technical support or other training, it will be charged. So there is a free training for let's say 8 hours a day.
Okay.
Okay, so that's for free.
Okay. Okay. Okay.
Okay, sir.
Yes, I think.
And by the way, you will find a lot of training videos on our channel for pressure vessels, heat exchangers, some real samples. For storage tanks, you will for the lifting procedures, how you can make it on SEG software. So we have many training videos. You can watch it and learn how to make the items by using SEG software.
Okay. Okay. Great, Mr. Ahmed. I think we are looking forward for this software.